Hello, I wanted to go through this example of how much heat is released when 24 grams of ammonia or NH3 is formed. Okay, and so we have this reaction where we've got N2 gas plus 3H2, so hydrogen gas. Those two gases come together and react and form 2 moles of ammonia or NH3 gas. Okay, so we have 1 mole of nitrogen gas, 3 moles of hydrogen gas, forming 2 moles of NH3 gas. And this reaction has a delta H of negative 80 kilojoules. Okay, and so that negative right here, we'll draw it down here, is an exothermic process. So negative means that it's going to release heat. Okay, so exothermic, release heat. So overall, this whole process, we're releasing heat. Because of the way this is written, so we have this balanced equation, right? And our delta H, that means if we use 1 mole of NH2 and excess H2, it's going to produce negative 80 kilojoules of heat, okay? And so we can use this equation and our delta H values with stoichiometry. So I'm just going to write 1 mole of N2 equals negative 80 kilojoules. And have 3 moles of H2 gas will produce 80 kilojoules of heat if we have excess nitrogen. And then also if we produce 2 moles of ammonia NH3, we're going to get 80 kilojoules. So this is actually sort of like stoichiometry in the fact that we can convert from moles of one substance to kilojoules of another substance. Okay, so when we write this out, remember we got to have our plan. And when we have our plan, we start with what we know, and we know, or what we have, is 24 grams of ammonia. Okay, and we want to know how much heat is released. So we start with what we know / have, and we go towards what we want. And what we want is kilojoules of heat. Okay, so we're going to connect these dots, grams to kilojoules. Now, when I have this balanced equation, I know that for every 2 moles of ammonia, I produce negative 80 kilojoules of heat. So I know if I get to moles of ammonia, I can get to kilojoules of heat. Okay, so 2 moles of NH3 equals negative 80 kilojoules of heat. And then the last thing to connect these, right, we have NH3 and NH3, so we're going to go from grams of NH3 to moles of NH3. We're going to do that using the molar mass. And let me see. My molar mass of ammonia is 17.04 grams per mole. Okay, so we can use that as a conversion. So when I'm going to start actually calculating, what I'm going to do is start with what I have. So I have 24 grams of ammonia. Next, when I look at this, right, so I'm starting here, now I'm going to get to moles of ammonia. So every time I have my arrow, I'm going to have a dimension. So my first dimension here is going to have molar mass. So I'm going to put my multiplication sign in, and grams of NH3 are at the top. So when I have my molar mass here, my grams are going to be at the bottom. So 17.04 grams of NH3 equals 1 mole of NH3. Okay, so that's my next dimension. And if you look, grams at the top cancels with grams at the bottom. NH3 at the top cancels with NH3 at the bottom. And I say cancels, but if you guys take and put grams divided by grams, right, same number, it equals 1. So we can cancel that out because it basically reduces down and equals 1. Okay, so I've done my step number one, and now I have another arrow. So if I have another arrow, and we'll do green, then I need to have another dimension. So I'm going to take multiplication, do another dimension. And this is going to be my second step. In my second step, I'm going to go from moles of NH3 notice moles of NH3 here, and I'm going to go to kilojoules of heat. So if I look at my balanced chemical equation, I see that 2 moles of NH3 equals negative 80 kilojoules of heat. Since moles are at the top over here, I'm going to put moles at the bottom. Equals negative 80 kilojoules. And I always just put that negative sign in because that negative sign tells me direction. So negative means exothermic, heat's being released. So I keep it in there. So when I look at this, I've got moles at the top that are going to cancel with moles at the bottom. NH3 is going to cancel with NH3 at the bottom. And I'm left with kilojoules of heat. So I'm going to take and multiply my top number. So 24 times 1 times negative 80 and divide by my bottom numbers, divide by 1704, divided by 2. And my calculator gives me a negative number of 56.338 kilojoules. So 56.338 kilojoules. Okay, I'm going to look back at the numbers I was given to determine significant figures. So here I have 2 significant figures. Here I've used 1, 2, 3, 4 significant figures. This number, 2 is a count, so we don't worry about that. And then negative 80 is a measurement. There's not a decimal place. So if you say there's 1 sig fig or 2 significant figures, you would be right, just because that number doesn't have a decimal. But because it's written there, I'm going to just say 2 significant figures. So I want to report my number in 2 significant figures. So negative 56 kilojoules. So what that says is if I take and form 24 grams of ammonia, it's going to release, right? I have that negative number, release 56 kilojoules of energy. So again, a negative, it's exothermic, and heat gets released. If you have any questions, feel free to drop them down in the comments and I will answer them or do more videos when I can.